very good evening to one and all present over here. My name is Rajat Verma and I am here to present the title of my interest, that is traditional learning versus machine learning. Along with that, I am also going to explain the different types of learning that are basic in nature. Now, moving on to the next slide, we have the first topic of today, that is traditional programming. Traditional programming is the old version of programming, or I would say learning. But when we see its structure, we see that there are two types of inputs over here in the case of traditional programming, that is data and program, that combines as a input over here that goes inside the machine, that is the computer. But what we are giving as a result, we are getting the result as an output. Now, the second case over here is the case of machine learning. In the case of machine learning, what do we have actually over here is the first input, along with that we also have the output. But in the case of machine learning, we don't have that, what kind of algorithm we are using. So, or how we are going to do it, or how we are going to get the output. So, what we are going to fetch over here, in the case of machine learning, we are going to fetch the programs, or I would say the algorithms. Now, moving on to the next slide, we have the types of learning. If we consider the types of learning that are basic in nature, we have these three types of learning. That is, the first one is basically the supervised learning, the second one is the unsupervised learning, and the third one over here is the reinforcement learning. Now, why it is written like this over here? That is known as train me. What is the meaning of train me? Now, there must be an entity who is going to train the learner. That means, who is the learner? Who is basically learning the things. That means artificially. Now, over here, that is train me. Train me is done by basically by the teacher. Now, over here, the second case is that in the case of unsupervised learning, I am self-sufficient in learning. Now, what do you mean by this? It means that there is the absence of teacher. There is no teacher. There is no teacher. Now, if I talk about the third one, that is known as reinforcement learning, that is totally dependent on the concept of feedbacks. If the feedbacks could be any, either it could be positive feedback or it could be negative feedbacks. Now, let us understand these of the machine learning techniques in depth. Now, moving on to the next slide, I can consider that what is actually the supervised learning. Let us have a description of that. And supervised learning is basically the one where you can consider the learning is guided by the teacher. Now, what is the teacher doing over here? The teacher basically provides the inference rules. The teacher basically provides the inference rules over here. Now, what does the inference rules means? Inference rules are the guidelines that the learner follows. And who gives it? The teacher gives it. The teacher gives advices or the inference rules to the learners to go ahead in the program. Now, over here, what is supervised learning? Supervised learning is that we have over here a data set. Now, what is a data set? What is a data set actually? The data set, I guess, is the description of the data that is saved as an external entity on which we are going to apply various of the models of the machine learning. For example, it could be linear regression, or it could be logistic regression, or it could be decision trees, or it could be SVM, or it could be random forest, or any kind of machine learning algorithm could be there. So we can use data set for these many algorithms and so on. Now, over here, what does it do? Let us see. We have a data set. Now, data set, I guess, is the collection of data that is basically saved as an extension of CSV, that is comma separated values. Along with that, it can also be an extension of Excel. Now, we have a data set which acts as a teacher, and its role is to train the model or the machine. Now, once the model gets trained, it can start making a prediction or a decision when the new data is given to it. Now, this could be more explainable with the help of a flow diagram, and let us see what is it. This is basically a very good, I would say, block diagram of supervised learning, where this are the inference rules, I would say, where these are the n inputs, and correspondingly there are the n outputs as well, where the input number 1 and the output number 1 are mapped together. The input number 2 and output number 2 are mapped together. Similarly, the input number 3 and output number 3 are mapped together, and so on. We can have n number of inputs and n number of outputs that are mapped together. Now, based on this data that is provided, and this is basically provided by the teacher. Now, whatever data has been obtained from this particular database goes inside the entity where it basically proposes an algorithm. Now, what does this algorithm do? Based on this algorithm, a model is being prepared, and from this, on this model, I would say the unknown inputs will be tested, and if we are getting the desired results, we can say that the model is working properly and the algorithm is correct. And if for any of the input values, if we are not getting the same answer, then we can say that the model is not working properly and there must be certain kind of problem in the case of learning algorithm. So we need to rectify it. So this is basically in the case of supervised learning only, where the learner can able to prepare a model. But in the case of the other algorithms, there is no case of model over here. Let us see. Now, if you are focusing on the concept of unsupervised learning, now this model learns through observations and finds structures in the data. Why? Because there is the absence. The teacher is absent over here. The teacher is absent over here, and once the model is given a data set, it automatically finds the patterns and the relationships in the data set by creating clusters in it. Now the point is that what is the cluster? If I talk about of a random shape, suppose if I am taking a random shape like this can be considered as a cluster number 1. If I take a secondary shape, this can be considered as a cluster number 2. Now I would say that there must be certain number of elements that are available in cluster number 1. And there must be certain number of elements available in cluster number 2. Now, what is the point in the making the clusters? Now, cluster will be having the elements denoted by suppose x in the case of C1 and dot, or I would say a small line in the case of C2. Now, over here, the element, that means this x and this x will be highly similar. But if I am going to compare an element of C1 with the element of C2, they will be highly distinguished. That means the elements of C1 will not be equal to the elements of C2. So, we cannot add the labels to the cluster over here, and like it cannot say that a group of apples as an example or mangoes, but it will separate all the apples and the mangoes. That means all the apples will belong to cluster number 1 and all the mangoes will belong to cluster number 2 because of a certain shape and size. But we cannot give them a label that the elements belong to C1 are basically the apples and the elements belong to C2 are basically the mangoes. Now, over here, suppose we presented images of apples, bananas and mangoes to the model. So what does it? Based on some patterns and relationships, it creates clusters and divide the data sets into those clusters. Now, if a new data is fed into the model, it adds to one of the created clusters. Now, let us see a block diagram of the unsupervised learning for a better understanding. Now, see over here that in the case of unsupervised learning, first of all, you can see that there are only inputs and that to n in number, and there is no output. There is no output because there is the absence of teacher. The teacher is not present over here. So, whatever the algorithm thinks, or I would say the input considers, that basically evolves into an algorithm. Now, there is no, I would say, model to deliver this. Now, what are we going to do over here? Now, in the case of a learning algorithms, we are making the different types of clusters over here, where the elements, this can be considered as C1, this can be considered as C2, and this can be considered as C3. Now, the elements available over here in the cluster number 1, the elements over here, let us consider that they are denoted by X, and over here, suppose that they are denoted by minus. Now, what is my intention over here? My intention is that, first of all, we are not making a model over here. That means there is no model. I'm sorry of my handwriting because I'm writing with the mouse. So, there is no model over here. So, what does it do? It basically self-teaches himself. Since there is the absence of the teacher, there is no teacher, so the learning algorithm prepares itself. How does it do? By preparing the clusters. Now, what we have seen before, that the elements of the cluster number 1 will certainly not be equal with the elements of the cluster number 2 and certainly not be equal to the elements of the cluster number 3. But if we are comparing the elements of the cluster number 1, they will be highly similar. They will be highly similar. If I am going to compare the elements of cluster number 2, they will be highly similar, abbreviated as HS. And if I compare the elements of cluster number 3, they will be highly similar. So in this model or in this manner, I would say the unsupervised learning works. And you can see by the meaning only over here, this is unsupervised. That means supervised and the removal of un. That means the removal of teacher over here, that is why it is known as unsupervised learning. Now, the third, or I would say the last type of learning is known as reinforcement learning. Now, the simple concept is that the reinforcement learning is basically dependent on the term of feedback. Now let us understand what is the little theory about it. It is an ability of the agent. Now how the agent comes over here? The agent is the person who performs some actions in the environment, right? Now actions, how does it do? He basically interacts with the environment and finds out what is the best outcome. Now this is a never ending technique. That means reinforcement learning will only stop until and unless it is when the reinforcement learning will only stop when the agent is getting the best reward. It will never settle for a second highest reward. It will never at all. It will never settle for the best. It will never settle until unless the agent gets the best reward. Now it follows the concept of hit and trial method. The agent is rewarded or penalized with a point for a correct or a wrong answer. And for the correct, it can be considered as a positive reward, and for a wrong answer, it can be considered as a negative reward, as we've discussed previously. And on the basis of the positive reward points gained through the model trains itself. It trains itself, and when it will stop until unless it is getting the best reward. And once again, train it gets ready to predict the new data presented to it. Now let us see the block diagram of it. Over here, let us consider that agent is there who is performing some actions at time t in the environment, and based on the feedback given by the environment, it must be having a state and it must be having a reward, and this reward could be either positive or could be negative, and that state could be happy or could be sad or could be any as depicted. And based on that, now this will be acting as an input for the next state. Now as you can see that this was the concept of very basic example of reinforcement learning. So let me give you a very quick example of reinforcement learning. Suppose there is a butler who is working in a hotel. Now suppose your family goes over there and stays inside that hotel. Now at the receptionist, the butler comes and the family meets. Now the butler asks the family, so please give the luggage, and after taking the luggage to the respective rooms, if the butler does not commit a single mistake, then we can consider that he can get a positive reward in the form of the tip from the parents' family, or I would say the family that came to inside the hotel. And if some wrong term or some wrong task has been performed by the agent or the butler, I would say, suppose if example while traversing the luggage inside the respective rooms, the luggage fell down, and suppose there is imported crockery that falls down and breaks down, then what will happen? Then what will happen? I guess the family will not be happy with the actions of the butler, right? And if it does, that means he will not be getting a tip. So the butler will think that he has done a mistake, and if he has done a mistake, now it is time to change the actions so that it can get the best reward next time. So I guess you have understood the concept of reinforcement learning, and thank you so much.